Why Kubernetes? Remember when you first started programming? You didn't need to know how your computer managed your memory for you. The operating system did that for you. Today we're going to see how Kubernetes does the same thing for cloud applications and why that changes everything for developers. In 2023, I started working with Kubernetes for the first time. Like many others, I felt overwhelmed by its complexity. But then I realized something that changed my perspective entirely. It helped when I thought about Kubernetes as if it were an operating system for cloud applications. And just like you don't need to understand all of Linux to write applications, you don't need to understand all of Kubernetes to already use it effectively. In this video, I focus on application developers who haven't used Kubernetes yet and are trying to make sense of it. What are cloud applications? I just used the term cloud applications. Let's see what cloud applications really are so that we both understand what I mean by the term.
Cloud applications, also known as cloud apps or cloud-based applications, are software programs that run on remote servers instead of on your local device. These applications are accessed through the internet, typically via a web browser or specialized app.
Think about what an operating system does for you as a developer. When you write a program, you don't have to worry about the CPU core that will execute your code, how the system allocates memory pages, how disk I/O scheduling works, and how networks route network packets. The OS handles all of that for you. It creates abstractions that let you focus on writing your application logic. Through system-level calls, you update data structures that live inside the kernel that do these things for you. Now let's look at what Kubernetes does for you, but then for cloud applications. When you deploy an application in Kubernetes, you don't have to worry about the server that will run your container. We call that also the Kubernetes node. Provisioning of cloud storage, restarting your application after a crash, and scaling up your application based on a metric of your choice. Just as an OS manages computational resources, Kubernetes manages your computational workloads, which are the pods that you run in Kubernetes. But you do have to tell which application image to use, how many copies you want to run, and which of these applications might receive internet traffic, for example. In fact, let's map some concepts you already know to their Kubernetes counterparts. Processes in an operating system are like pods on Kubernetes. An operating system manages processes. Similarly, Kubernetes manages pods, the smallest deployable units. The OS determines which CPU core runs your process, when Kubernetes selects which node hosts your pod. Running a program requires having it on disk to launch it from a shell, whereas running a pod involves submitting a YAML file to the Kubernetes control plane, which will then download the image to a Kubernetes node and start it for you. Your program requests memory from the OS without knowing about physical RAM layouts. Similarly, your deployments request resources from Kubernetes by claiming just CPU and RAM, but Kubernetes will then find a node for you where those resources are available. Operating systems use file system to abstract disk I/O away. In the same way, Kubernetes employs persistent volumes to hide storage complexity from the cloud. The underlying storage could be AWS EBS or Google Cloud Storage. You don't need to know which or even how to provision it. Kubernetes will do that for you. Simply claim the disk space that you need in your deployment, and Kubernetes takes care of the rest. Where Linux gives you terminal commands like ps and kill to control your computer, Kubernetes provides kubectl to manage your entire cluster. But the power goes way beyond just starting and stopping things. Through upgrade strategy settings on your application, you can control how pods are replaced with a newer version once you roll one out. That allows you to keep the traffic on your website going or the processes in the backend without having to take it all down and restart everything, which will lead to downtime of your application. Think about running applications on your computer. You monitor CPU and memory usage, maybe auto-adjust process priorities. The operating system makes sure that processes can run and terminate the ones that violate certain boundaries. Kubernetes goes further than that and operates at cluster scale through horizontal pod autoscaling and vertical pod autoscaling. It makes sure that a sufficient number of pods running to deal with a measured workload are available, and it can automatically adjust memory and CPU requirements for your pods for applications that happen to need more. This automates the cluster management process and also reduces the downtime that you would have for pods that do not meet those requirements. But what happens if you want some constraints on network connectivity, for example? Because when you run everything on the cluster, all of those pods can talk to one another, isn't it? Well, a networking engineer would usually set up firewall rules so that these applications are limited into what they can call and what they can connect with. In a similar way, network policies in Kubernetes allow you to restrict the connectivity between pods in different namespaces. That way, your application can manage which other applications you allow to connect to it, and you can also manage what other resources your applications can connect. If you're spending a lot of time managing infrastructure instead of building new application features, that is when it makes sense to look into Kubernetes to solve a lot of problems that you would typically encounter. Blue-green deployment, zero downtime deployments, upgrades, and also rollbacks. Does your team need continuous deployment and zero downtime? It is a lot easier to do that in Kubernetes than if you have to do that manually through different tools. Do you need your application to run reliably or dynamically at scale? Automatic upscaling, automatic vertical scaling with more CPU and more memory? Or if you're working with microservices, the complexity of managing how the network needs to be configured and which applications are dependent on others should be a lot easier with Kubernetes. If you answered yes to any of these, Kubernetes is definitely worth exploring. The learning curve takes about 3 months to master the basics you will need, but remember, you don't need to understand everything at once. Start with the basics, just like you did when you learned about programming and operating systems, and then take it from there. You can think of Kubernetes to cloud infrastructure, what an operating system is for your computer. A learning curve of 3 months is better than spending 3 months on a custom-built infrastructure management solution that has no future. Focus on learning what you need for your specific use case, not the whole thing at once. The complexity that Kubernetes manages for you is complexity that you will have to manage anyway with any other solution.
Engineering Crucible. Building tomorrow's tech leaders by demystifying complex technology, maximizing impact, and improving collaboration.